Okay, a few seconds. So all the players here, all the participants, we have Osaka University, we have UMD, we have Goddard, we have Roman itself, and of course this is under the lead of us and JAXA agreement. And unfortunately, Dominic Benford, who actually wrote us a letter, who actually handled the whole arrangement, couldn't participate in the conference. He was supposed to be here, but he didn't make it. So, okay, so we went through that, Neil. So, well, this was already mentioned before, that this is a copy, this telescope is actually a copy or very similar arrangement as MOA, so which was good. So we are following in the footsteps of something that has been developed. And here's what it ended up with. These are all the parameters, almost 2-meter telescope, plate scale, focal length. So it's pretty fast arrangement. So it required pretty elaborate image corrector here. And here's our camera right behind that. So the design actually went through pretty rigorous design and optimization between the instrument and the dome. So we needed to have enough space between the front end of the instrument here and the dome. So collection was affecting the cost and schedule and everything else. On one side, on the dome, on the other side, it was affecting us, how much space we had here. So it's actually pretty tight. So, but I will show you more about that. So that's the whole arrangement. So if you look, so that's the whole assembly of the observatory, including the telescope, then the lens corrector, the 4 lenses. This little blue thing here, that's the door. So this is. Yeah, and this orange box, that's a worm assembly, which is the electronics and everything else. So it took quite a bit of a design to actually make it optimal. So around the detector, so these are 4 detectors. Then we have 4 KDs, and that's a creation of Marcus Luz with the Roland team. And then 2 Macy's, which is warm electronics. So these all are cold. These guys are warm. So part of the development, and that's what Marcus did for us. 1 Macy can handle 2 KDs, make it more efficient and also cheaper. So that was part of the development. We have what I would say is an amazing piece of hardware. Raise your hands who involved or knows about cryo instrumentation. 1, 2, 3, 4, 5, 6 people. Okay, right. Maybe the rest of you would not appreciate that, but the cryo coolers here allow to do the whole cryo cooling within a tight space of the instrument, so we didn't require any external compressors. So this box essentially is the whole assembly of the instrument. What comes into that is 3 lines. One is the communication. So that's the whole control, data transfer, and AC power, and 3, the water chiller, so to keep it chilled. And here's all our team members, or some of the key members. Greg Mosley, I'm sorry, Yuki Hirao, Joe Durbach, you will hear him later, and Greg is working on the detector assembly. So that's the whole instrument, partially assembled with the cryo coolers. So these little things, again, this is really technological marvel. Detectors. So this little box that contains all the detectors. And here's Greg working, assembling the KDs. So these little yellow boxes, gold boxes, these are KDs, and these are cryo cables to get to the detectors and to the outside So these are models. So that's how it went inside of the door, the cages, detectors, and then on top of them, all our filters mounted on the filter wheels. So this is all, mind you, this is all cryogenic space. The filters are really gigantic. So these wheels are like, 16 inches in diameter, and all works at cryo temperatures, amazingly. So this is a little bit of repetition. So this is mounted on the telescope. Another technology or engineering development, and that was done by OU side. Although we participated on the options on how to design these lenses to optimize to the detector. But again, this kind of pancake arrangement for the door, we try to make it as small possible to optimize everything, because the space, as you see, pretty tight, and then the dome is right over here. So that's all goes in. As I mentioned before, important part is the thermal insulation around the electronics deck and cryocoolers, because as David was mentioning that we need to optimize for whatever imaging quality, seeing quality is, and part of that, whatever turbulence we are causing inside of the dome, and this thing, and it's getting pretty warm. It's sitting right inside the beam of the telescope. So we did a distant installation. The best we could find were yoga mats. That's what came out of it. The instrument was built from March 2020 to July 2022. As you may recall, March 13th of 2020 was the start of COVID, at least in the US. So everything was shut down. So we were planning originally to do that within a year. But unfortunately, because of COVID, we had to extend it for another, 9 months, 10 months. So it was pretty tight schedule, but we were able to do that through that. And by July, the camera actually had everything in it, including the readout. The readouts were kind of risky. Again, I have to tell you that all this is a frontier for technology development for spaceflight hardware. The detector, of course, were available, but we had to mount everything in the door and characterize them. But the Acadias were not packaged. And we got packaged Acadia somewhere between like February to March of this year, Joe? Yeah. So by March. So it was very, 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 very tight. So between March and July of 2022, we had to complete the assembly and prepare that for shipping. So we actually shipped it in July 2022. Another question, originally we were considering to use a leech controller. So, and Leach was kind of a person who did infrared readout systems like for the whole IR community. So question to you, who's familiar with this name, Leach, Bob Leach? Not that big, probably a dozen people. So, and we were actually planning, and we actually bought some Leach, next generation Leach controllers, but soon after that, we got the news, Leach sent a letter to everybody, goodbye, everybody, I'm retiring, and I'm dissolving the company. So everybody who was using Leach controllers, they were left in the cold. So our decision to go with the Acadias was actually good, even though it was risky. We were in a very, very tight spot for delivering, but in the end, it worked very well. So telescope construction, August 22, and then September 25 to October 12th, that was commissioning. And here's a beautiful image of JRD 221009A, the brightest event ever. We were lucky, so it was like the second night we were on the sky. So, and for us, for our team, transients, GRDs, and gravitational waves is the primary interest, of course. So we're working towards that. There's lots of development on the software is going on. We're on track. So I'm not going to go through other technical details of the issues, but for the last year, the instrument has been operating uninterrupted. So right now it's been warmed up. So by the time everybody goes for the dedication ceremony, it will be warm. But we're planning to, like I said, that we're going to replace the window to make the operation easier, and we'll start another cycle for another year. So the only issue that is kind of unfortunate, we couldn't get the detector as cold as we were planning to get them. So the dark current is a little bit higher than we wanted it to be. But in general, everything operates, and now that's a matter of observing, refining the processing software, and get more data, and keeping up with 100 terabytes a year, and hosting and everything else. Anyway, so that's all I had to say.